In this video, we will talk about scalability, and most of the content of this video is from this book, Designing Data-Intensive Applications. If you are interested in system design, I highly recommend you to read this book. In our previous video, I have talked about reliability. If a system is working reliably today, it doesn't mean it will work reliably in the future. The reasons may be perhaps the system has grown a lot of concurrent users, or perhaps it is processing much larger volumes of data than it did before. Scalability is the term we use to describe a system's ability to cope with increased load. When we talk about a system's scalability, the questions we need to ask is, if the system grows, what are our options for coping with the growth? How can we add computing resources to handle the additional load? We need a way to describe the current load on the system. And then we can discuss the growth questions. Load can be described with a few numbers, which we call load parameters. For a web server, we use requests per second. For a database, we use the ratio of reads to writes. Let's consider Twitter as an example. Post-tweet is a main operation. Post-tweet means a user can publish a new message to their followers. There are 4.6K requests per second on average, and over 12K requests per second at peak. And the data we used was published in November 2012. Home timeline is another main operation. A user can view tweets posted by the people they follow. There are 300K requests per second. There are broadly two ways of implementing these two operations. For approach 1, posting a tweet simply inserts the new tweet into the tweets table. Tweets table is a global collection of tweets. And to request home timeline, we need to join these three tables. For example, if the currently logged in user with ID 101, we will first find all the users that they follow, and then find all the tweets of these users and merge them. The first version of Twitter used this approach, but the system struggled to keep up with the load of home timeline queries. For approach 2, it maintains a cache for each user's home timeline. It's like a mailbox of tweets for each recipient. When a user posts a tweet, it will look up all the people who follow that user and insert the new tweet into each of their home timeline caches. Then, the request to read the home timeline is then cheap because its result has been computed ahead of time. But the downside of this approach is that posting a tweet requires a lot of extra work. On average, a tweet is delivered to about 75 followers. So 4.6K tweets per second become 345K writes per second to the home timeline caches. So in this example of Twitter, the distribution of followers per user, the 75 followers, this is a key load parameter for discussing scalability. In online systems, what's usually more important is the service's response time to describe performance. Response time is the time between a client sending a request and receiving a response. In this figure, each gray bar represents a request to a service, and its height shows how long that request took. Most requests are reasonably fast, but there are occasional outliers that take much longer. In this figure, so the response time, it is better to use percentiles to describe performance. And in this example, median is 200 milliseconds. That means half your requests return in less than 200 milliseconds, and half your requests take longer than that. So median is a good metric if you want to know how long users typically have to wait. In order to figure out how bad your outliers are, you can look at higher percentiles like 95th percentile. 95th percentile is 1.5 seconds. That means if there are 100 requests, then 95 of them take less than 1.5 seconds, and 5 of them take longer than that time. Now we have discussed the parameters for describing load and metrics for measuring performance. We can start discussing scalability. How do we maintain good performance when our load parameters increase by some amount? There are typically two ways: scaling up, also called vertical scaling, moving to a more powerful machine, and scaling out. Scaling out is also called horizontal scaling, and distributing the load across multiple smaller machines. Distributing load across multiple machines is also known as a shared nothing architecture. In this video, we talked about scalability and talked about how to describe a performance and how to describe a load, and we use response time percentiles as a way of measuring performance. And most content of this video is from this book, Designing Data-Intensive Applications. If you are interested in system design, I highly recommend you to read this book. Thank you for watching this video.